to Math 120, the lecture for section 6.6. Today we're going to be talking about logarithmic and exponential equations. So as you look at example 1 on your handout, the directions say solve each equation, and then the second sentence, express irrational solutions in exact form and as a decimal rounded to 3 decimal places. So what you have to be careful about on this one then is that those directions are only talking about irrational numbers. So numbers that can't be written as a fraction where it's an integer divided by an integer. So there are a lot of items where that second sentence really is not going to apply. So let's go ahead and check out a few of these problems. Our first one, example 1a then, we have log base 5 of the quantity 2x plus 3 is equal to log base 5 of 3. Now, as you look at this problem, notice that we have a log on the left-hand side and we have a log on the right-hand side. There's a rule that we talked about in section 6.5 that said that if you have the log of somebody on the left-hand side and the log of somebody on the right-hand side, as long as the base is the same, the only way that this statement can be true is if the arguments themselves were equal. So we have the base of 5 on the left, we have the base of the 5 on the right. We do have the same base, so that means that this has to mean then that the argument on the left, 2x plus 3, has to equal the argument on the right, which is 3. And by doing that, we now have a nice linear equation that we can solve. So in order to solve this linear equation, I'll subtract 3 from both sides. I get 2x is equal to 0, divide both sides by 2, and I end up getting x equals 0. Now, at this point, you have to be kind of careful when you're looking at logarithmic equations, because remember, if you think about the graph of a logarithmic function, these logarithmic functions are only defined for positive x values. So if you're looking at an x value and you plug that x value into any of your arguments and you find that any of your arguments are either 0 or negative, we're not going to be able to use those x values. So what we have is that in this section, sometimes we're going to have solutions that are extraneous, which means they came out of the process of solving, but they end up forcing our argument, at least one of them, to be either negative or 0, so we can't use them. So at the end of every logarithmic equation, you need to double check your answers. So let's go ahead and double check this. If I plug in an x value of 0 into this first argument, it's going to be 2 times 0, that's 0, plus 3. That means that I have an argument of 3. 3 is a perfectly acceptable number. 3 is a positive number. I can take the log of a positive number. So yes, that's perfectly fine on the left-hand side. On the right-hand side, my argument is 3. Again, 3 is a positive number. I can do that log. So on this particular problem, I don't happen to have an extraneous solution. So x equals 0 truly is a solution. So it's a nice thing then to come in and make some kind of notation to describe the fact that not only did we go through the process of solving and get this x value of 0, but we also came in and checked, and it did actually check. So on the board, you'll notice that I underlined, but the author actually likes to come in and write his final answers as a solution set, just to reiterate the fact that he has come in and he has checked the answer. And yes, it worked in the original equation, but it also is not extraneous.